Okay, so in the last video, I told you about the formulas for the mean and the variance of the binomial distribution, right? They are pretty simple. And this is a very straightforward application of the formulas. So the parameter n is 10 and p is 0.2. So the expectation is n times p, n times p. So 10 times 0.2 is 2. So A or C or E. And then the variance is n times p times 1 minus p. So n times success probability 20% times failure probability 80%, which is 1.6. Right, this is the answer. Okay, I believe it's pretty easy. Okay, now I'm going to show you two more examples, two more applications of the binomial distribution. So the first one is kind of continuation of our previous example, reservation and overbooking. So let's think about this story. Airlines sell more tickets than seats available, expecting cancellations. We call that overbooking. It's pretty common industry practice. And suppose that for simplicity, an airplane has 20 passenger seats. So technically, it cannot accept more than 20 tickets, right? Or it cannot sell more than 20 tickets. And the airline sold 22 reservations, expecting like two of them would cancel. So, and assume that the probability of cancellation is 10%, and all the cancellations are independent across reservations, as following the binomial distribution assumption. And we are going to now, in this example, I am interested in the number of reservations that are not canceled. Not canceled. That means this is the number of passengers, travelers who actually want to take the flight, right? How many travelers is going to come to the airport, okay? And then we know it's binomial distribution, but before studying the distribution, we have to set its parameters. What are the parameters? This is the most important question, but I see many students are not confident how to fix the parameters. Okay, think about it. So the options are pretty simple, 20 or 22, and 10% or 90%. First, let's think about what we are counting. We are counting the number of non-canceled reservations, right? So in this case, if you count that, that is success, right? So suppose that we have 22 reservations, and suppose that 2 are canceled, 20 are not. In this case, then y equals 20. So then that means we are counting non-cancellation as success and cancellation as failure, right? So and remember, p, the parameter p is the probability of success. But as I said, success is just what you count. It can be different. If you count how many cancellations, then p would be 10%. But in this example, what we count is those who came to the gate, airport gate, right? So in this case, cancellation is failure. Failure probability is 10%. So the success probability is 90%. So it's tricky. I understand that it is pretty tricky, but that is it, what it should be, right? So because you may count how many questions you are wrong, or you can count how many questions you are correct. Basically, they are the same thing, but you have to adjust your parameter according to what you count. On the other hand, n is the range. Remember, range the range of the outcome. In this case, what is the maximum number of non-cancellations, maximum number of travelers who come to the airport? That is 22, right? So it does not matter how many seats in the plane, but what we have is 22 reservations. So because like if no ticket is canceled, there are all 22 non-canceled reservations. That is the maximum. So the parameter n should be 22. Okay. So again, when you think about parameter, first, like to determine p, you have to think about what is the success, what you are counting, right? And that's probability of that outcome is p. And when you think about n, you have to think about just maximum possible outcome, right? What happens if everything is success or everything is failure? So then n is pretty straightforward. Now, then let's think about the probability of the airline in trouble. Like there are only 20 seats, the capacity is 20, but 22 people came or 21 people came. So then it's in a trouble. Have to compensate the one or two people. So we are interested in the probability y greater than 20. So there are 20 seats, but there are more people who want to take the flight and already have the ticket, right? So then how do we calculate that? This inequality, probability of inequality, cannot be handled directly in binomial distribution. So we have to break down the inequality into multiple equalities. Like in this case, probability greater than 20 is either probability equal to 22 or 21, right? There are only two simple cases, greater than 20. So you have to calculate probability for each of the equality, right? So this is when no cancellation happens. So out of 22 reservations, all 22 tickets are still valid. So that means 90% happened 22 times and 10% did not happen. So actually you don't multiply 0.1, right? The exponent of 0 means you do not multiply 0.1. That is probability of 22. Now probability of 21 means there is only one cancellation. So out of 22 reservations, 22 are not canceled, right? There could be 22 different scenarios, Only if one is canceled, it could be the first reservation, second reservation, up to 22nd reservation. One of them is canceled, so there are 22 different scenarios. And then non-cancellation happened 21 times, and cancellation 10% happens once. Okay, so you calculate that, and you will get 33.2, like 92%. So nearly one third is the probability of not enough seats. So this overbooking policy has some problem. Okay. Okay. So now then, similarly, I will do the same thing, but I will see what happens when you decrease the number of reservations so you do not overbook as much. Previously, you are selling 22 tickets with only 20 seats, but now you are selling only one more. Okay? So then, let's think about the change in the problem. How much is the change in the probability of the trouble? Okay? So, try it by yourself. First, do it by yourself. I'm going to use Excel to do this. So probability. So first thing you have to tell here is you have to specify the parameters. So there are 21 reservations now. So at most there can be 21 travelers who want to take the flight. And the probability. In this case, still we are counting the ticket holders coming to the gate. So it is 90%, those who do not cancel. Probability of not canceling the reservation and just want to take the flight. So these are the parameters. Now we are calculating probability greater than 20 defined by inequality. It's not convenient to handle, so you have to change it to a equality. So because n most y can be 21, the only case the airline is in trouble is when all the 21 ticket holders come to the airport. How do we calculate that? You can just use binomial distribution formula, right? You have to input like many things. First, number of success, 21, and number of trials, 21, probability of success, 9, and cumulative, false. If you type this and enter, you are going to get this probability. So that is C. Okay? So this is how you calculate the binomial distribution using Excel. So of course, I taught the formula, but I don't expect you to memorize the formula, and of course, I don't expect you to calculate do the algebra based on the formula. Use Excel, right? However, I want you to understand the mechanism behind it. So here, the reason why I wanted to show you this example is, so think about the change in the probability. Previously, when you sell 2 more tickets, the probability was 33%, which is huge. But just by reducing 1, it came down to 10%, or about say 11%. So the probability became 1/3 of the previous one. So the change, when you change things, the change in the probability is not as intuitive as you expect, right? So all the numbers earlier, I gave you a very counterintuitive example, brain teaser. Similar, it's not easy to just guess how much probability would change. So in the binomial distribution. So I gave you this example to see that. And you get the result like this. As I said, 21 out of 21 reservations, we are worried if all 21 tickets are valid, not canceled. And that means 90% happened 21 times and 10% did not happen at all. So it's 10.942%. Okay, let me do another question, another example. Now it is quality control, quality inspection. Suppose that there are firms manufacturing batteries for EV, electric vehicles. And assume that the probability of a battery defective is 5%, right? That's possible. So the automaker, the vehicle maker, receives shipments of batteries from battery manufacturers, but automakers try to screen the quality of the batteries. Like if too many batteries are defective, the automaker will return the batteries back to the manufacturer. So inspect it. So for simplicity, let's suppose that the auto manufacturer inspects randomly chosen 10 batteries from a shipment, right? From a container, for example, randomly choose 10 batteries and check if they are good or not. And the vehicle manufacturer accepts the shipment, the container of batteries, only if 2 or fewer batteries are defective out of 10. Right? In this case, I'm going to define Y as the number of non-defective batteries from the inspection of 10. Okay? Then, what is the probability that the batteries, the container of batteries, are rejected? Think about that. Okay. Also, this is it is not algebra. It is translating the question into mathematical equations and notation. So you have to get used to it. Think about it. So first, accepted, the batteries are accepted only when 2 or fewer batteries are defective. And in other words, it will be accepted only when, so by the way, we are counting non-defective batteries. So the batteries are accepted only when Y is 8 or greater. Here I'm counting defective batteries, but Y is defined based on non-defective batteries. So we are counting different things, different sides, right? But in the end, they are the same thing. So accepted if Y is greater than 8. However, I'm asking you about probability of rejection. So it is rejected if Y is strictly smaller than 8. Like, so if Y is 8, then accepted. But if Y is 7, then it is rejected. So the answer is E. Okay? So, okay, right? If the number of non-defective batteries is 7, that means there are 3 defective batteries. It does not satisfy this condition, so your batteries will be rejected. Okay? So that's the condition. The answer is E. Okay? So it's tricky. Like, it is easy to make tricky questions, but so you have to be careful what you are doing. And we are going to define the parameters first. Y is the number of non-defective batteries. And remember, N is the maximum possible outcome, which is 10. When you inspect 10 batteries, at most you can see 10 good batteries, of course, right? If everything is good, that would be 10. And P is the probability of good batteries, which is 95%, because 5% is probability of defective batteries, then the other 95% is probability of success. In this case, success is good batteries. That's what we are counting. And we are going to calculate this probability. That should go like this. So inequality is not convenient in binomial distribution. So you need to do this. But this is even more complicated. You have to calculate 8 different probabilities. So in practice, you have to use the other side of the inequality. I would calculate 3 probabilities instead of 8 and just subtract from 100%, right? So here I am calculating probability of rejection. But I don't need to calculate this. I may calculate the probability of acceptance, and just then the flip side is the other probability is rejection probability. So in this case, as you can see, calculating acceptance probability is easier because it only needs 3 probabilities. Okay? Okay, so, oh, typo, I'm sorry about that. It should be the other side. Anyhow, the probability of rejection is only 1.5%. Pretty small, right? And what I wanted to show you like before I finish this is cumulative distribution. Cumulative probability for binomial distribution. So I just showed you the probability Y is smaller than or equal to 7. So you may calculate this by splitting the probability into multiple equalities. But actually on Excel, what you can do here is, say, number of success is 7 and 10.95, and just choose true. If you choose true, then it will return cumulative probability, which is of this form. We learned cumulative probability in Chapter 3. Cumulative probability is probability up to 7, including all the smaller values. So it's true, then exactly this is this probability. So I will show you the difference. This is the difference. If you choose false here, I choose false here, then it returns this probability, probability of equality, right? Which is different. But if you input true, then it will return inequality up to that point, including equality, like greater than or like smaller than or equal to. So this is CDF true, and this is CDF false. So in Excel formula, you have to tell which one you are looking for and enter the correct command, true or false. Okay, this is the end of chapter 5, and we started a new like statistical model. And next time we are going to learn another statistical model called the normal distribution, which is really important. Okay, see you there. Bye.